Today I'll be talking about lambda expressions. So lambda's expressions are pretty much anonymous functions. So when you previously defined a function, you would define a function like this. So you would go such as define f(x), and then we could specify a value at f at x. So for example, we could say it's plus 2x. So when we have a function like this, it's bounded to a certain parameter. So we could go like f3 and then it would return this. So this is equivalent to how we have f at x in math. And you substitute a value for x and then it pops out from the values within the domain and pops it out as the range. So this is a normal function. Now binded to this function you have the identifier f, but in a lambda expression you no longer have an identifier. So here we take the example of add. So in my add function I have a lambda expression that has two parameters, x and y, and I add x plus y here. Now here I have another function, and I call it OP, so operation. It accepts three parameters, x, y, z, and then we do z to the x to the y. And now this is actually legal in a scheme, because what we basically have is we have a function called OP that accepts a parameter, so we could have any. So we could have a function, let's say this is type x. We accept another type x, and I might do the contract wrong, but for the next function, we have something that accepts x and it produces y. So we pretty much accept a function here. So we accept z, and when we do OP, we accept 1, 2, and add. So the parameters of 1 and 2 are actually arguments that can be placed for add, and then add produces a separate value y. So we can see this here, we actually parameter pass a whole function in here. So in reality what it's doing is it's actually substituting in the add lambda function, and then the lambda function takes out these variables and sticks them in as parameters. So the neat thing about this is if I want to reuse OP, I could make another one called sub, and it actually subtracts it, and I could just simply substitute this in. Now, you can think of this way. When you do a quick sort, and I may be doing this wrong, hopefully I get the syntax on point. But when you do quick sort, okay, so I got it. So I'm going to comment these out. So when you do quick sort, you actually send in a operator. And this operator specifies, it's like the compare to in Java. If you ever use that. So it's a comparator operator. So it accepts two parameters and you want to compare the two. Now this is actually a lambda expression. If I substitute in here a lambda xy and I return a boolean, this works. Because it takes in the x, takes in the first value and the second value, and returns true when the first value is less than the second value. How about we only return true if let me move these around. I'll scramble them for you guys. Only return true if x is equal to 3. You can see what happens here. So it scrambles it and puts the 3 at the beginning, because 3 has the lowest priority. So no matter where we put the 3, it should actually just put all the 3's in there. So we see here, which is pretty neat, we can actually use quicksort to put all of the elements in a particular order. And it seems like it preserves the order of the 4, 1, and the 2. This is actually really interesting. So we can actually stick in a or x equals 3 or x is 1. Oops, messed up on the brackets. Lots of brackets in Racket. Yeah, so we can see here we got 3, 1, 4, 2. So it's perfect. So as you can see here, we actually implemented a anonymous function, function into the quicksort method. So we allow the comparing two values. So I hope this makes sense for you guys. You have to practice a little bit. Grasping the concepts of lambda, it's a little bit difficult. You have to imagine it as a method with a function with no name. and then it accepts whatever parameters go outside of it. So I could do something like, yeah, you just have to play around with it. That's really all there is to it. So I hope you guys enjoyed this video, and thanks for watching.